Okay, picking up where we left off, we just finished talking about character encoding. So one more time, from a telegraph's perspective, two major kind of foundational things is, one is imposing a signal on a wire and doing encoding and decoding. That was a fundamental kind of things. Okay, so let's move on. On page 9, they talk about multiplexing. So multiplexing is a way to combine multiple channels onto one wire. And the idea is that without multiplexing, if I wanted to have 4 telegraph conversations going on at the same time, I had to have had 4 wires, or actually 4 pairs of wires, strung between the 2 places. And you can imagine that kind of gets expensive. So with multiplexing, I can have multiple conversations going on over the same wire at the same time. So Samuel Morse put together the Morse system, and then Thomas Edison in 1874, 30 years after the thing came out, came up with a way to have 4 conversations going on over the same wire. So that's a practical and economic reason for doing this, practical. Otherwise, every time you wanted to add an extra person, extra conversation on, that would just be terribly expensive. So multiplexing, its ability to combine things together. There's kind of a symbol here that I'm going to jump ahead. So this is kind of sort of what multiplexing looks like from a practical point of view. It's not exactly right because we haven't got the switches yet, but I have like 3 different people trying to talk. I have an A person, a C person, and an E person. They all try to talk, and what happens is they all got imposed onto the same wire. Okay, that's kind of what that means. We'll get back to that in just a minute. Okay, page 10, the next one is switching. So we did the telegraph, we did multiplexing, now we're doing switching. So switching on page 10 basically says that one wire can go many places. That kind of makes sense, doesn't it? Again, if I wanted to have a wire going from my conversation from let's say Washington, D.C. to St. Louis, I'd have one wire. But if I wanted to go to a wire from Washington, D.C. to San Francisco, I couldn't use the first piece and just tack on. I had to run a whole new wire. Every destination had to have a separate wire. If I had 5 destinations that I want to talk to, I had to have 5 wires for the complete line. So switching kind of made sense. Switching meant you get a situation where here, if B wants to talk to C, well then okay, you had to have a wire, and if B wants to talk to D, you had to have a wire, and so there's 6 wires here. And you might think, well, that's not too bad, but add like 2 more onto this, and this gets very complicated in one heck of a hurry. So 4 doesn't look that bad. The model with 5 or 6 looks like spaghetti, tons and tons of wires all over the place. The idea is a switch would be everyone would connect to some sort of a central switch, and the switch would just connect you when you needed it. Kind of sort of simple, right? Not really that difficult to understand how that works. Anyway, so that's what switching is all about. Now, just think back from a historical perspective. You guys have probably seen movies and stuff where you had telephone operators, right? So in the old days, this switching actually occurred by human power. You called up the operator and said, I need to talk to Aunt Mabel. And they pulled a wire out of a plug board and plugged it in. They made a connection between your wire and Aunt Mabel's wire. So it was a switch, but it was a manually operated switch. Okay, fast forward a bit. Then we ended up with the rotary dial phones. And you might think, oh, well, that's ancient history. Well, man, not quite so ancient. When I came to Fort Hood, they made the switch from rotary to tone dial in the early 80s. Yes, it was kind of crazy. You could go in a phone switch room. There were mechanical switches. Every time somebody would dial, they had these little motors mounted on these racks, and they would go click, 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 and they would be just making all the. In fact, it was a very noisy room because it was like hundreds and hundreds of these little motors all moving when people were dialing their phone. So it went from human powered to mechanical powered, And then obviously now we're into what some people call touch tone dial switches, where the computer just listens to the tone and automatically makes the switch for you. So those are the three different ways that switching has occurred. On page 11, they finally talking about packetization, kind of a crazy term as I mentioned. It's all what's called packet switching. So before we can even talk about what packet switching is, we got to talk about what a packet is. So essentially, packet means I have to break a conversation into small chunks. And each chunk is basically put in an envelope. It's not that much different than, let's say you wrote a novel and it's got this many pages in it. And you took each chapter and you put it in an envelope and sent it to your buddy. Then you put chapter 2 in an envelope and sent it to your buddy. Over and over and over and over and over. And when the person at the other end got it, they would open up all the envelopes and all the stuff would be there and it would be all in the right order. So that's essentially what packetization is. Take something big and break it up so it fits into the envelope. Not that big a deal. If your envelopes are very small, then you have to break it up into mini chunks. If you have big envelopes, maybe not quite so much. And so the envelope, so to speak, has to contain the destination address. It has to, somehow the system has to know where to go to deliver that. Okay, now the sending system doesn't really care about where it came from, right? It just got here magically. It only cares about the destination. Okay, and the cool thing about this packet switching is I'm not using the wire at all times. I put something in an envelope and I send it on the wire. And I put something else in an envelope and I send it on the wire. So there's periods of time when I'm not using it, which is really kind of cool because that means other people can use it. Cool. All right. So it allows for shared use. And so that way I can be listening to music, surfing the web, or uploading a file all on my same machine at the same time, and it doesn't cause problems. And now we're back to this little thing. So I have 3 computers, and one of them is either sending or receiving. It doesn't really tell me here. Some A data and some B data and some E data. And so packetization breaks these things up into tiny little pieces and then spits them out. And it makes it look like I'm the only one here. My video or my music's coming through nice and smooth and no chops. And so I'm just assuming I'm the only one on the entire internet. Well, obviously you're not. But the packet switching makes it look like that. So breaking it into packets and sending me just tiny little chunks is a very, very efficient way of doing business. Let's kind of go through the technical details of how this works. Okay, the first one is step 1. You got to break the data up into chunks. So if I have big data, I gotta cut it up. That's step 1. Step 2, every chunk is been numbered and addressed. In other words, it's got to know its sequence, because if they got out of order, right? If I got chapter 3 before I got chapter 2, I won't know what your novel is about. So they're numbered and addressed. Then I send the chunk to wherever it's going to go. I have to wait for the receiver to basically tell me they got it. Otherwise, I just say, well, I put it in the mail and I assume you got it. And then the person at the other end has to reassemble the chunks. So there's an awful lot of things that have to happen in order for packetization to work. They make a discussion about, on page 13, circuit switching versus packet switching. Okay, so circuit switching means just like dialing the phone. In the old days, you would pick up the phone and you would dial grandma, and they would make a connection, a honest to God wire connection between me and grandma. And so I'd say, hey grandma, and I created, but it took a while, right? I mean, it took me a couple seconds to dial the number, and it took a seconds for grandma to answer the phone. So building up that circuit and tearing down that circuit is kind of expensive, so to speak. Not money perspective, but from time and energy, it's expensive. Okay, so that's what circuit kind of switching is all about. So circuit switching temporarily connects my phone to grandma's phone. I mean, my phone's not normally connected to grandma's. It's just only when I want it to be. It lasts the duration of the conversation, and then it's dropped, right? And there are some issues. In the old days, and we are talking about old days, not current. In the old days, you were told, don't be on your phone during a thunderstorm. And the idea is, I honestly, God had a wire connecting my phone all the way through the city out to the woods to grandmother's house we go. A single wire was connecting the two together, and if there was a lightning strike, it is possible that me or grandma could have been electrocuted. Okay, so that's not really the way it works now. I mean, there is some, but yes, honest to God, physical wire connecting the two together. Packet switching. Packet switching is like your modem on your computer, which is basically always on. Now, circuit switching is temporary. It's only on while I'm talking, and when I'm done talking, I disconnect, right? Packet switching it's on at all times, just waiting for something to occur. It uses these things called routers, which we have an entire chapter on, so don't freak out over that. That basically looks at all this stuff and says, I know what to do, I'll pass it on to the right people. And it's designed to be fault tolerant. And there's kind of a historical perspective behind this. Way back when DARPA, the I don't remember what DARPA stands for. Anyway, Army Research Projects Agency. Anyway, Advanced Research. Okay, got it. Anyway, when they were kind of putting together this whole idea of a network, they wanted to have it so, and this sounds gruesome, so just bear with me. They wanted to have it so that if a major population center got wiped out by a nuclear attack, that messages could still go around the busted area. In other words, it was designed to be multiple paths connecting Los Angeles to Washington, D.C. So not one single point of failure in there could break communication. It was designed to be fault tolerant. And we'll go into that in a little bit more detail a little bit later on. Okay, the last of the four things that we talked about on page 14 is this packetization. Of course, packetization and packet switching kind of go together, right? I mean, you can't have one without the other. So again, breaks it into chunks. They're labeled and addressed. Cool. And let's say that you're Walmart or something, and you ordered I don't know, 1,000 coffee makers. Excuse me. Are you going to get from the vendor? Are you going to get a cardboard box that has 1,000 coffee makers in it? One giant cardboard box? Probably not. What you probably get is like 100 cardboard boxes with 10 coffee makers in it per box, right? So the manufacturer packeted them, didn't they? They put them in 100 cardboard boxes. Each of the cardboard boxes has a label on it in case one of the boxes falls off the truck somewhere. Somebody could look at it and go, oh, this belongs to Walmart, and it would finally get there, right? Okay, so that's all packetization it is. It's not rocket surgery or brain science. So, another analogy, of course, is writing a letter. I write a letter. I put information in the letter that I want the recipient to receive. And then I put information on the outside of the envelope for the postal department to see. I put it and send it off. And I'm having a conversation with somebody, but it takes, days for things to happen. Okay, so packetization is kind of sort of cool. Now, the only issue about packetization, and we'll talk about security kind of things a little bit later, but is the idea that anyone could open that cardboard box and see the coffee makers inside. Or anyone could open the letter and see my letter to Grandma. When this thing was originally designed, it was not originally designed to be a secure environment. Their thinking at the time was, all these are legitimate users in a friendly environment, and we can share data back and forth. That's the only thing they were thinking. Much later, they came out and said, well, that was a dumb idea. Let's see if we can harden this thing. But it wasn't originally part of the plan. Okay, this is probably a good place to start for the 15-minute mark, and we'll pick this thing up again in just a few.